tutorial, we are continuing with circle theory, that is plane geometry 2. In my previous video, we have talked about the first 3 theorems, and in today's tutorial, we are going to dive deeper into the other theorems. So follow the video till the end. Don't forget to leave a like so that YouTube can promote my video to a lot of audience. In that way, you are helping me. And again, subscribe so that when I release any other new video, you will not be left out. So let's get into the video. Please get a jotter and follow. We get a starter here, and this starter is just a recap of what I have done in the previous video. I'll put the link in the description. You can go and check it out for yourself. Thank you. Now, the starter says that work out the missing angles and state your reasoning. So circle theorem is full of formulae and reasons and theorems. So you will have to give reason to every theorem you use. Which theorem did I use to get the answer? Okay. So it says O is the center. O here is the center of the circle, and AD is the diameter. The diameter divides the circle into 2 equal parts, making 2 semicircles. Okay. And then we have a complete circle. Now we have a quadrilateral ABCD. CD inside the circle, and that's what we call the cyclic quadrilateral. So let's go ahead. It's supposed to find all the missing angles. We don't know C, we don't know B, we don't know D, we don't know F, and we don't know E. So we are going to find those angles. Now, B is 58. From the previous theorem, we say that angles that is subtending from the diameter to the circumference is 90 degrees. So if here is 90 degrees and here is 32 degrees, you use the properties of the angles or triangular theorem. So when I sum all the angles in the triangle, it must give me 180 degrees. So that is why when I take 32 plus 90, that's going to give me 122. And you subtract 180. You take it from 180 and you are going to get the remainder as what? 58 degrees. Now we're going to get C. Looking at this angle, so this line and this line, they are all equal because this is a radius and this is also a radius. Radius OA and radius OC. And when they are all radius, they are all equal. This line and this line. That's why I've shown this. And if they are equal, it means the base angles are also equal. So you are looking at this an isosceles triangle. Isosceles triangle have 2 lines equal and 2 base angles equal. So it means that this angle is equal to this angle. So it means this is 55 and this is 55. That is, we know that everything inside here should sum up to 180 degrees. So if here is x and here is x, that's 2x plus 70 is equal to 180. Then you subtract 70 from 180 to get 110 and you divide by 2 to get each of the angles. Now we are coming to learn with these 3 other angles. Now that I know here, this is also 110 because it's on a straight line. Angles on a straight line sum up to 180 degrees. It seems like we are using 180 degrees a lot, but that is the property. So 70 plus what gives me 180, that is a semicircle. So you just add 110 to it, you get 180. So we know that this angle is that. Now the same, this line here, OC, is a radius, and this is the center, and it's also to D. It means that it's also a radius, so which means that this line here and this line are all equal. And if they are all equal, the same property we applied here, it means these base angles are also what? Equal. Therefore, this angle will be 35 and this will also be 35. Alright, so let's get into the video. You can pause it anywhere you don't understand and replay to understand it before you continue. If you don't understand anything, put in the comment section and I'll be happy to help you out. Now, we have one of the theorems which says that we have looked at this, that is in the previous video. Okay, semi-angles theorem. It means that this angle here is 90 degrees. Angle subtending from the diameter to the circumference is 90 degrees, and I've mentioned that in the introduction. We also looked at this. We have also looked at this in the previous video. I'm just recapping so that you can go and watch. The link will be kept in the description. So this angle here is half of the angle here. This angle here is half of the angle here, right? So it means this angle is twice of the one at the top. So today we will learn another rule that can be used. So today's one, we are going to look at the problem that use it alongside the rules we already know. So we'll look at some examples in relation with the one I just stated earlier. So angles in the same segment are equal. Angles in the same segment are equal. Let's look at what a segment is. So angles in the same segment are equal, and we are applying the bow tie rule. So if I have a circle and I have this diagram drawn inside there, so we are saying that when we have a segment, so the angles that are there, when we have a segment, the angle 34 is equal to the other one also over there. The same way to the down one here. If this angle is 12, this angle is also 12. Why? Because we are saying that they have the same segment, illustrated by the red line. The same way, we can have another segment at the top, but this one is called the minor segment, and the other remaining one is the major segment. So if the subtending from the minor segment, those two angles are all equal, and that's what we call the bow tie rule. You can see that it looks like a bow tie. We can get another one. So this angle 34 is equal to the other one also over there, right? Yes, so similar as that. Let's look at another one. So if I have a circle and I have drawn, so you can see that there will be a segment here, and we are saying that this angle here is equal to the angle here, and this angle here is equal to the angle here, because we have just stated that over there that they are all from the same segment. Okay, this is another one. So this angle here is equal to the angle, and that is equal to this angle illustrated there. So if here is 65 and here is 21, what will be here? No matter the size, but it's still equal to this one. So here is also 65, and here also what? 21. So it's a property you can apply. So this is what we call the bow tie rule. I have just want to make it understandable for you, so it looks like a bow tie. So anytime you see it looking like that, you should know the properties you are going to apply, because they are all having the same segment, or this one, and the remaining one will be the major segment. Let's use that to solve one example. So follow thing. Now we have been given two of the angles, but we don't know Q, we don't know P, and we don't know R. From the bow tie theorem, it says that this angle here is equal to the angle here, because they are all subtending from the same minor segment. So when you look at angle P, it is also 27 degrees, because they are all in the same segment. So it means P is 27. Now we can look at angle Q. If you want to use the alphabet to name that, we have A, C, B, or B, C, A, referring to the same angle Q. It is also 29 degrees, referring to this one, because they are all from the same segment. You can either use this one or the other one. Now that I know this and I know that, I can find this because they are all in a triangle. So we can have triangle B, O, the center is O, and here's C. It's forming a triangle. So I can find R. When I sum everything inside these three angles, I must get 180 degrees, which means that my R will be equal to 124. So I just take 27 from 180 and 29 from 180, and I'll get what? 124 degrees. Alright. So here is 124. The next example, calculate angle WXYZ from the information given. AD is the diameter. So once they are giving us a diameter, we'll be able to apply some previous theorem we have looked at. Okay, know the diameter. We define X, Y, Z, and W. Okay, so W would be what? You can apply some of the properties we have just looked at to easily get it. If I remove the diameter, you can see that it looks like the bow tie that we have just looked at. And if here is 15, here should also be what? 15. If here is 15, here also be 15. You see that? So they are angled in the same segment. So W is 15 degrees. If I know this, I can find some other angles. So I'm bringing my diameter back. Now, the theory says that if we have an angle subtending from the diameter to the circumference is 90 degrees. So X will be what? 90 degrees. Looking at the red line. So it's forming a right angle over at the top there. So angles in the semicircles always form up to 90 degrees. So it means that X is 90 degrees. If I know X and I know W, then I can find Y. So if I sum everything inside here, it should give me 180 degrees. So 15 degrees plus 90 degrees will give me 105 degrees. I take 105 degrees from 180 and I'll get my Y. So Y is equal to 75 degrees. Angles in a triangle always sum up to 180. So Y here is 75 degrees. Now, and that was Z. But you can also see that it is on a straight line over here. It is on what? A straight line. So it means that when I sum whatever that is here, it should give me 180 degrees. So now, if here is 75, then here will be what? We can find that. So here is going to also be 105 degrees. Angles on a straight line sums up to 180 degrees. There is a particular property in plane geometry 1 which states that the sum of two opposite interior angles is equal to one exterior angle. So the exterior angle is here, so we are considering this triangle. This one is outside of the triangle. So it means two opposite. The sum of this and this will give me this. Right. The next example, fill in the missing angles. So we have about 4 or 5 angles missing. A, B, C, D, E. All of them are missing. So we got to find them. So first look at A. Let's see. Okay. You can take your time and go through it again. If you can do it, that's okay. If you can't do it, come back to the video. Once again, if you like the video, don't hesitate to put the finger there so that YouTube can promote the video. And again, you share to friends, subscribe, and hit the bell icon so that when I release a new video, YouTube will notify you so that you will know. Alright, so you can see that this angle here, A, is on a straight line with a 79 degree. And we said the angle on a straight line sums up to 180 degrees. So I can add 79 plus A and equate it to 180. So it means that to find that A is equal to 101 degree. 101 degree. Because when I sum this, I'll get 180 degree. So when you find A, when you add this and you don't get 180 degree, it means you are wrong. You check your answer. Because angle on a straight line must sum up to 180 degree. Okay? Now look at B. I know this angle, I know this angle. So angle in a triangle sums up to 180 degree. So 19 plus 101 is going to give me 120. So 120 and the whole thing will give me 180. Then B is equal to 60 degrees, right? Now let me see. You can find that C is this angle here. If I know this angle, I can find this using the bow angles property. So the bow type here. Angle in the same segment. Angles in the same segment. So I can find C to also be what? 60 degrees. If here 60, it's 60. If here is 19 degrees, what will this one be? Using the same theory, you can easily get that, right? So here is 60, here will also be what? 90 degrees, right? Because they are also in the same segment. And then with E, it's done with E. We can also find E, right? Looking at the same property here, right? Z. Yeah, so when I pick this angle here and this angle here, they are equal. From here to that, from the whole of this angle, the two of these should be equal to this angle. Okay, Z properties or alternating angles. So if here is 19 degrees, but the whole thing should be 60 degrees, so take 60 minus 19 degrees, and I'm going to get what? 41 degrees. That's alternating angle. So E here is 41 degrees. So simple. How do we use that formula? Why do we use it? It's because of the arrow here. That shows that this line CD and line AE are parallel lines, and parallel lines do not meet. So once you see those parallel properties, you'll be able to use the parallel lines properties inside there. That is in plain geometry 1. So you can, I'll put the link in the description. I have a video on it, so you can go and watch it out for yourself. Alright? And please, just to mention, the items I'm using to do this video recording, initially, if you look at my previous video, it's faceless. I just use only my laptop. But now I got the tripod stand, and I have a projector, and I have a microphone that I now use to help me deliver my content and my knowledge to the audience for you to understand. I'll put the links in the description. You can go and also look for them out and buy from Amazon. Thank you. Alright, then we look at the proof of this theorem we are looking at. Look at the proof of the bow tie theorem. We want to prove it. So we have been using it. By now you understand, but what to prove it, how it is. So imagine I have this particular diagram, and we have a situation you have just seen now, like this. Mark the center of the circle. So I mark there and I say O. Remember, this is not X, this is the center I just marked, and this is the one I labeled as O. Now we want to join the center to point A and B. So you join the center to point A and B. Okay? This is the rule from last lesson that we look at, the previous lesson, which I state that the angle here is twice the angle here or here. So this angle is half of what is formed here. Okay? So if we call the angle at the center 2x, then both angles at the top will be the same, that is x. If I label here as 2x, then here will be xx because this is twice of the angles this week. Here is 2x, here will be what? X, right? And here also will be x. Good. Just follow. So we say that this is 2x, here must also be xx. Again, remember that that center is labeled as O. That's the property we just looked at. Now, a cyclic quadrilateral is a quadrilateral that can be drawn on the edge of a circle. So when we have a quadrilateral is a four-sided plane figure. So if it is inside a circle, then we call it a cyclic quadrilateral. Right? This is a quadrilateral. So if I have a circle around it, then it's called a cyclic quadrilateral. This is another one. If I have a circle around it, then it is called a cyclic quadrilateral. If I have another one, so it doesn't matter. Once it's a quadrilateral, a four-sided plane figure, and then we have a circle around it, then it's called a cyclic quadrilateral. So just to form the concept of what we mean when we hear cyclic quadrilateral. Okay. So opposite angle in a cyclic quadrilateral adds up to 180 degrees. So the one we just look at, we say the opposite angle sum up to 180 degrees, which means that this angle here plus this to give you 180, this angle plus this to give you 180. Opposite angles should sum up to 180 degrees. So if here's 85, then the other one will also be 95, because when I sum them, this will give me 180 degrees. Likewise, if here's 88, then here will be 92. So that when I sum them up, they'll give me 180 degrees. Again, if I have another quadrilateral here, it means that this angle here, if here is 30, then here will also be 150 degrees because they are opposite. And this are also the same. So if here is 140, here to go to what? 40. So that when I sum them up, it will be 180 degrees. Just look at it. Cyclic quadrilateral. So once the quadrilateral, look at it that the angles are the same when they are opposite. Okay? And then we can have another one here. This angle and this angle also sums up to 180, the same to that. So if here is 99 degrees, then here also 181 degrees. If here is 77 degrees, then here will be 103 degrees. Because when I sum this plus that, I'll get 180 degrees. Now, this theory is well laid, well established. Opposite angles in a cyclic quadrilateral sums up to 180 degrees. An exterior angle in a cyclic quadrilateral will always be the same as the opposite interior angle. Wow. So if I have this, and here is this angle there is 73. It's also 73. That's what it means. Remember, it's extending to the exterior angle. There's tangent there. It is 73. If here is 88, then the opposite here will also be 88. Exterior angle means it's not inside the quadrilateral itself. It's not inside the quadrilateral. Okay, so the opposite exterior angle equal to that of the interior angle. So this is opposite to this angle. Remember, the reference is not to the circle, but the reference is to the quadrilateral. Opposite. You can see that the reason. If here and here to give you 180, so here will be 1. And if that figure is here, when you sum this, you should get 180 degrees, which means this is directly equal to that. Okay? Once we take more examples, you got to understand. So if here is 104, here also 104. Okay? Because when you find this angle here, because they are opposite, when you sum them up, it should give you 180 degrees. So if I find this angle here, it is going to be 76 degree. So here's 76 degree. I'll add this up, I'm also a straight line, and I also get it as 104 degree. You can see that. That's why the property is saying that this angle here is equal to the exterior angle over there. So here is also 104. If I know the exterior angle, then the same as that of the one inside here. Now this is another one. Please, you can pause the video and tell me the other ones in the comment section, and I will know if you are following. Okay? If here is 86, I can find here because they are on the same straight line, right? They are on the same straight line. But you can quickly get the answer because the property is saying that this angle here is equal to the angle here. So it means they are the same. And then we can equally get here to 45. The sum of this will give you 180. So if this plus this will give 180, then it's wrong. 45 plus 135 is 180, which means that this angle here is equal to the angle here. The same way when you add this, they are on a straight line, is to give 180. So bring it like that. Now let's solve this. Please apply the properties. I want you to look for A, B, and C. Put the answers in the comment section before you continue. The first person to do that, I'll give you a gate. Yeah, the gate will be a book to read. Alright. Now A, B, C. I know 93. I'll be able to find this because when I sum them up, it should give me 180 degrees. I know this. I should be able to find this because this angle should sum up to 180 degrees, but we might not use that. This angle here is equal to the angle B because this is an interior angle is equal to the opposite exterior angle. When I sum this and this, it will give me 180. So I can find A. So A is 68 degrees, angles on a straight line. That will give 68 degrees. I find here. B, this classes give you 180. The reason that opposite the interior angle. Opposite angles for the exterior angle will give you one. The same thing. Opposite the exterior angle. And when you sum them up, you get 180. So you can use that property as well. I can get C. So C is also equal to 87 degrees because when I sum 93 plus 87, I'll get 180 degrees. Opposite interior angles of a quadrilateral. A quadrilateral gives you 180 degrees. Alright. Work out angles P and Q and explain how you got your answers. So mostly like I said in sector theory, the emphasis is on the reasons you are giving. Why are you saying this angle is equal to this angle? Why are you saying that this angle is this? So if I'm saying that P is equal to 61, if I'm saying that P is equal to 51, why am I saying so? Okay. Also, when I'm saying it's 51 and I give the reason, and somebody comes and says 61 and give the reason, and you see that that reason cannot apply well, then you check which of the reason is correct and mark the person's correct. So here I can find P because there's a reason that states that this angle here is half of the angle here. It means this is twice of the angle here. So now that I know this angle, I can find this angle. So and P will be equal to 51 degrees because angles and the circumference is half the angles at the center. This angle is half of what is it. So divide it by 2 and get P. Again, I can find Q. Opposite interior angles of the quadrilateral sums up to 180. So this plus this will give me 180. So if I know here, then I can get here. But there's still another property you can use. Right? Here, I know you're 51. Now, the property we want to use is that this is we are considering quadrilateral because that one is here. A, B, C, D. Why won't we use A, O, C? Well, this one is not touching the circle. Okay, because it's not touching the circle, we can't say that this angle plus this will give me 180. It is rather this angle plus this angle that will give me 180 degrees. And I can find this and also say it's twice of the angle here. So Q is equal to 129 degrees. Opposite angle to the cyclic quadrilateral sum up to 180 degrees. So I know it to be 51. I can find it here, right? So we are considering this one, not this. Like again, this is not touching the circle. So all the quadrilateral sizes must touch the circle. That is, the vertices must touch the circle before you can use that particular property. Now, the next example. Find x and y in this. Line A, C is the diameter. Once you hear a diameter, you'll be able to apply some other theories. You can see that this line here and this line are also parallel, which means you can also apply the parallel lines properties. So you look out for which properties am I going to use. Remember, there's not only one property that can be used to find an angle. So just look out for the one that you know and think you can use it to find it. And don't take one of them, just use one. Alright? I will mention the different type or different ways of answering the question, but you can just choose only one when you have been asked to do that. So from the parameter stated here, it's saying that AC is a diameter. So which means that if AC is a diameter, angle subtending from the diameter to the circumference is 90 degrees. So here is 90 degrees. Okay? And say it's 90 degrees. We don't need it, but I could have used that to also find here. Because this angle plus this will give me 180. Okay? Now we can use the parallel lines property. This line is parallel to this. This angle here is alternating to this angle. So this is Z angle. So I can quickly find C. So realize that instead of going to find here, come to find here, and it will be a long process. So just apply the short properties that you see inside here. This angle is equal to this, which is the angle X. Alternating angle. These arrows give us the audacity and the knowledge that it is parallel lines, because the arrows showing that they move and they never meet. Parallel lines never meet. Okay? So left with the y. And we can look for y also. If yes, 43, we know here to also be 43. And left with only one angle, right? So let's see. Angle y. Considering this is a triangle, and this line here is equal to the line here, because this OD is a diameter, sorry. Okay. OD is a radius and OC is also a radius. That's why these lines are here, showing that this line and this line are equal. And that is an associate triangle formed inside them, which means that these base angles are equal. If here is 43, then here is also what? 43. Okay, and I can now find this angle here. But again, we know that angle subtended from a diameter to the circumference is 90 degrees. So we know that from this place is 90 degrees. And I mentioned here earlier that here is also 90 degrees. Angles, opposite angles in the cyclic quadrilateral sums up to 180. So here is 90, here must also be 90. This is very clear for you to understand. Now, if here is 90, I take 43 from 90 and I'll be able to get the remainder as y. So it means that my y will be equal to y plus 43, that will give me 90. Angles in a semicircle. So the property is angle in a semicircle. Because this diameter divides the circle into 2 semicircles. And the angle subtended to the circumference is 90. So that's why we are using the 90 over here. So it means y is equal to 47 degrees. Oh, thank you. Let's get the next example. We want to prove the cyclic quadrilateral property. We say that the opposite angle in a cyclic quadrilateral sums up to 180 degrees. So we want to prove it. The proving is very important, right? So let's look at it. So imagine we join two corners to the center of the circle. We join this to the circle, right? You can see a property that this angle here is twice the one at the top. Okay? If we label the top angle as x, then the down one will be what? 2x. The one at the center will be 2x because this angle is twice of the angle over here. We are trying to prove this property, that the sum of this and this is 180, and the sum of this and this is 180. That's what we are trying to prove. Okay? Do the same thing with the opposite angle, labeling it y first. So if I label it as y, then this side also be 2y. Okay? Yeah, that's supposed to be 2y. That's the property. So this is half of the angle here, and this is half of the angle at the top. So if here's x, here will be 2x, and here's y, here will be 2y. Now we can factor them out. If I want to add this, what will I have? Okay? If I add 2x plus 2y, it should give me 360 because they are on a circle. The whole of these angles will give me 360 round circle, right? So I can factor the 2 out, making x plus y. So the 2 going out, dividing 2, get 2 divided 360, that will give you 180. And then means that x plus y is 180. So it means this x plus this y is 180. That's what I'm saying. The opposite angle, the cyclic quadrilateral, sum up to 180 degrees. So just look at the property. Don't understand? Pause and re-watch it. Please don't forget to give me a like and subscribe. If you have a friend, you can share with them to also use that. Calculate the missing angles in each diagram. So this is just a linear for you. We know here to be 34. Here will also be what? So we are applying the bow tie property over here. Angles in the same segment are equal. Here is 94. So if I move this, we say that this angle here is twice the angle here because they are from the same segment. Like if you move this up, the same thing as the earlier one we looked at. The angle at the edge is half the angle at the center. Right. Thank you. We are gone far. So today we just looked at 2 other new rules to the ones that we already learned in my previous video. So you may need to use any combination of these in question, as well as be able to state which rule you have used. You should be able to state the rule that you have used. Okay, sometimes highlighting lines can help you see which rule applies. So in the video, you realize that sometimes I highlight some of them rest for you to understand it more. Thank you. And once again, I'll put in the description the things I'm using, the tripod stand, the microphone, and the projector for you to go and purchase it if you want to start doing something like this. Feel free to also DM me if you want a coaching on how to do what I am doing so that you can also one day make some online income. Thank you and have a nice time.